So in part B, we are told to consider a graph g of x, which is defined as mx plus 1. And in part 1, we need to write down the number of solutions to f of x is equal to g of x when m is larger than 0. So what we need to consider here is what this graph is going to look like. So we see that it has a y-intercept of 1. And in fact, our original f of x also has a y-intercept of 1 here. We can plug in 0 and we will see that it will come out as 1. And so if we have some positive slope, we will have like something like this. These all have positive slope. And we see that however we do this, there will be two solutions because one time it will cross over here and one time it will cross this bottom graph. So these lines will always have two solutions. They will have two intersections. And then in part 2, we are told to consider a value of m such that f of x is equal to g of x only has one solution. So that means they only have one point of intersection, which means that it will have to go something like this. And well, this is called a tangent, so we need to find the slope of this line pretty much. So we need to find the derivative of f of x at x equals 0. So we need to find the derivative of this function, which we can do through the quotient rule. So let's do that. So we need to take the derivative of the top first. So the derivative of the top is simply 2, and then we have to it's 2, and then we multiply it with the bottom function, so 3x plus 6. Then we minus the top, multiply with the derivative of the bottom, which is 3, and we divide it by the bottom squared. So we can simplify this a little bit. So on the top we'll have 6x plus 12 minus 6x minus 18 over 9x plus 2 squared. And this is further equal to minus 2 over 3 times x plus 2 squared. And well, we need to make m have the same slope as the function has at here at x equals 0. So we know m will be the derivative at 0. So if we plug in 0, we will have minus 2 over 3 times 2 squared, so 4. So that's minus 2 over 12, so that's minus 1 over 6. So that is the value of m that we had to find. And then for the last part in part B, we are told that we need to find the range of values of m such that this f of x and g of x have two solutions for x larger than 0. So that means that our graph has to intersect 2 times from like here on out, so when x is larger than 0. And well, what we can notice is that for there to be two solutions, so at minus 1 over 6, it was one solution. We know m cannot be positive because then there will be one of the solutions will be on this part of the graph. So we know m has to be smaller than 0. And well, if we think about it, if m becomes smaller than minus 1 over 6, then it's going to have some gradient like this, and our second intersection point will be here, which is on the left side of the y-axis. So it's for negative x's, but we want it to be for positive x's. So we need m to be larger than minus 1 over 6, and well, that is the solution.